Alright, so now we're ready for our last sort of regular module, last topic, that everybody will do the same for egr157, and that's counting and looping. It's module 13. We talked about the things that we can do and how one of them is to repeat something over and over again, and that's what looping is about. There's several types of loops. We'll look at a couple. The simplest one is called a for loop. And basically, you sort of need to know how many times beforehand you're going through it. And the syntax is for and end, like any structure in MATLAB. And then x equals an array, which is usually a range. Doesn't have to be integers, but that's kind of the way we think about it. It's going to go through one of what's in the array. And then whatever you want it to do in that loop, inside between the for and the end statement. Again, you want to indent so it'll be easy to see what goes with it. The array can be named beforehand, or you can just give a range. So the old-fashioned for loop is you just do an integer from 1 to 5 steps of 1, something like that. So here's a real simple one that I think I have uploaded that you can download and run, and it's just going to ask you for a starting point, a stopping point, and a step size, and then it'll display each number. So if I were to go 1 to 5 steps of 1, right? Then it would go start at 1, steps of 1, and stop at 5. So x would start at 1, do whatever while x is 1, so it'll display 1. Then it'll go back up and add the step. So 1 plus 1 is 2. Now it'll do it for 2. Go back up and add the step. So it'll display 3. It'll display 4. It'll display 5. And then it won't display anymore. Once it gets done, it'll go down to whatever's below your for loop. So run it for these different cases. Do 0 to 100 by 10s, for example, and see how it acts. And you can also go backwards, where you can go 100 to 0 if you simply give it a negative step, right? So let me go do that for at least one of those. So example 4, I think it was. Here it is. So if we run it, so in other words, if I put in a 1 to 10 steps of, let's say we do 2, then it's going to do 1, 3, 5, 7, 9. Okay? So do that. And here's another little bit more complicated example. That was also, I think, available for you to download. And this one, we're going to collect some data from a user. So we're going to ask the user, he's going to be taking some sample flow rates from a stream, possibly. And so we're going to ask the user for what's the time of the first sample, what's the time of the last sample, how many do you want? And then we'll input them and make a graph. So here's my code. I think this one's also loaded up there for you on Canvas. What's the initial sample time? What's the last one? 10. How often should samples be taken? Every 3 minutes. So it'll ask me your first sample, 0 minutes, your second sample, your third sample, and then it'll plot them. And I've made a plot, so we need to go down a little bit on this one so you can see the bottom. All right, let's see what that code looks like. Here's that code. So there's your inputs. We call it add start, add end. Now what we're going to do here, because we're going to be adding things to an array, the way MATLAB creates things, it turns out to be quicker if we'll make a blank array and then let MATLAB add to it every time. And so we're going to have an array ABS, empty vectors. We're going to put our inputs, and then ORD is and count as the number of samples. So we're going to go in our times. That's what's going to go here, and then we'll prompt, or he prompted for your sample, and he's going to, the count's 1, and I is my counter, so that would be whatever we put in. I think we did 0 earlier, right? And then you can see what it did. We had 0, 10, and 3. So sample number 1, because that's our counter, at 0 minutes, and then we wait and pick that flow rate, which is an input. That's that ABS equals ABS prompt X. Now what we're doing here is we're putting it in. See, this is the array A. So we're taking the old array ABS and putting it in, and then add 1 to it. And then our input, widget says flow rate Q, that's where I put in the 5. And then, so it adds to ordinate, which is going to be the flow rate, and then it'll click our counter. So that one automatically counts through, or we can click the counter. That's called an accumulator, by just adding 1. And then there's where we do our line. So we do abs in order, or X and Y. And then we do a lens space, pick those points. We do a polyvalve like we did before, and then we do a plot. And of course, that's what we come up with. So you want to analyze that one and understand how it's working. And then we're going to come to our PA26, which is a little bit more involved than some of the ones we've done before. I'm going to have you write a Fibonacci sequence. Now, Fibonacci sequences are extremely important in the history of math and the history of engineering because they're a simple example of a feedback loop. In math, we would call it a recursive series because what comes next depends on what happened before. This Fibonacci is easy to write. You need 2 seed numbers, and they'll be the first 2 numbers in your series and in our sequence. And so then to get the next one, you add the 2 before. So to get that one, I go 0 plus 1 is 1. To get the next one, I go 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. Or if I seed 1, 3, then 1, 3, and then 1 and 3 is 4. 3 and 4 is 7. 4 and 7 is 11. Etc., etc. And so that's what I want you to do, is to write a program that's going to ask for the 2 seed numbers. How many numbers do you want? And output the list of that particular Fibonacci series. Now, Fibonacci goes back to the 11th, 12th century. And I think in India they were doing it even in the 6th century, so it's quite old. You may have seen it in Cal 2 when you did series and sequences. I mean, you sort of have to make sure it covered. Not everybody does, but it's a really interesting series. Now, one of the cool things about it, why it was so interesting to people, is it actually has a limit. In other words, if you take the ratio of the successive numbers in the Fibonacci sequence, so you'd have to leave off the 0 here, but the successive. So you go 1 over 2, or 0, 1, 0, 1 over 1, 1 over 2, 2 over 3, 3 over 5, 5 over 8, 1 over 3, 3 over 4, 4 over 7. That number, that ratio, has a limit. In other words, if you take the limit of that, then it turns out to be called the golden ratio. I got a typo there. It's ratio, not ration, not ration. And it's 1 plus the square root of 5 over 2. It's called the golden ratio. Ancient Greece, there's a lot of different things that the golden ratio comes about. It turns out it pops up in biology a lot too, as the ratio of the number of things. But anyway, so I'm going to want you to output that too. So let's take a look at our actual program description. So here it is. That's what I said. There's I read it out. There's 2 examples. There's the limit, 1 over square root of 5 over 2. And I've given your algorithm. So your program's going to write that out. It's going to calculate the limit of the last 2, out the ratio of the last 2 numbers in the sequence, and then it'll output the golden ratio. Knew a guy who played the stock market based on Fibonacci. He would watch prices at the end of the day and take the ratio of the preceding days. And when he found a series where that was getting closer and closer to the golden ratio, then he would buy and sell stocks accordingly. So anyway, that's 26. If you have any trouble, make sure to send me an email. Shoot me a question. I'll help you. That one's going to be a little more complicated than some of the others we did, but it's kind of fun. Talk to you later.